These are spectacular space discoveries that leave us completely stunned. Today, we will show you the incredible extents that the structures of the universe can take. Are you ready to discover colossal structures and objects that defy your creative mind and text style? We will move from the powerful sun to an infinitesimal grain of dust, from the largest omnivores in the world to a giant distant star, passing by an undetectable giant that we even suspect could be a parallel universe. After today's video, your vision of the night sky will never be the same. The largest structure in the universe, the Hercules Corona Borealis Great Wall. In other words, the largest and most gigantic structure the observable universe has to offer. The term observable suggests that from our Earth-based perspective, it's not conceivable to observe the universe in its entirety, as the universe is homogeneous and isotropic. It always appears the same to an observer, regardless of their point of view or direction of observation. This results in a spherical space around our Earth, which delimits our cosmic field of vision. Due to the expansion of the universe, and the fact that distances already traversed have been extended by it, the distance reaches 46.6 billion light-years to this boundary of the cosmic field of vision. But let's return to the colossal superstructure. It shows an incredible size of 10 billion light-years. For comparison, the extension of the Milky Way in the galactic plane is estimated to be between 170,000 and 200,000 light-years. However, the Hercules Corona Borealis Great Wall comes with a significant limitation. We cannot say with absolute certainty that it truly exists. Before definitive proof of its existence is provided, astronomers refer to the unusually high number of gamma-ray bursts recorded in 2013 in the direction of the Hercules and Corona Borealis star groups. It is likely that this is a gigantic collection of supergalaxy clusters forming what is known as a fiber. However, one thing is certain. If the monster, located about 10 billion light-years from Earth, truly exists, it would not only be a sensational and revolutionary discovery, but also a cosmic mystery that would shake our models to their foundations. In this context, the galactic giant should not even exist according to our hypotheses on cosmological development. Structures that existed 3.8 billion years after the Big Bang should have a maximum size of 1.2 billion light-years. If the Hercules Corona Borealis Great Wall were ever proven to be real, we would have to completely revise our models of matter distribution at that time. The largest planet in our solar system. No other planet comes close to the impressive aspects of Jupiter. This mysterious gas giant has a diameter of nearly 140,000 kilometers. Theoretically, our Earth would fit into Jupiter over 1,300 times. However, the massive size of Jupiter is nothing compared to the exoplanet HD 1546b, located about 360 light-years from Earth. This distant world exceeds Jupiter's mass by 752 times. Excitingly, the planet is surrounded by a circumplanetary disk, meaning it continues to accumulate mass. Identified in 2014 as one of the rare exoplanets with direct perception, this planetary mastodon takes about 250 years to orbit its star. The largest star. When we look at representations of the giant stellar object Uy, we should indeed look twice. This is barely larger than a small grain of dust. It's our Sun. What represents the absolute maximum in terms of size and mass in our solar system seems terribly insignificant compared to the other structures in the universe. Located about 5,000 light-years away in the Scutum constellation, Uy eclipses our fixed star, with a radius over 1,700 times that of our Sun, theoretically offering enough space for nearly 5 billion suns. As a variable star, Uy experiences changes in luminosity over relatively short periods. Over a span of 740 days, it is at the final stage of its evolution and left the main sequence millions of years ago. However, Uy must concede defeat to another star in terms of mass and luminosity. These titles currently go to our 136A1, a Wolf-Rayet star about 1 million years old, which is 35 times the diameter of the Sun and 265 times its mass. At the same time, this supergiant in the R136 star cluster shines 10 million times more brightly than our Sun. In terms of temperature, our Sun also admits defeat, as its average surface temperature is 5,500 degrees Celsius, while our 136A1 surface temperature exceeds 40,000 degrees Celsius. The most fabulous black hole. In general, Nothing that crosses the event horizon of a black hole can ever escape it again. No radiation, no data, and certainly no matter. These cosmic omnivores literally destroy and absorb everything in their path. These gravity monsters can easily exceed the sun's mass by millions or even billions. However, we still don't fully understand the details of how supermassive black holes form, though one thing is certain. They are not the ruthless machines they are often portrayed to be. For an object to fall under the grasp of one of these entities, it must dangerously approach the event horizon. Outside of this death zone, black holes behave like ordinary masses that can be orbited on trajectories without any problem. Moreover, it is now certain that supermassive black holes occupy the center of almost all galaxies and play a fundamental role in their evolution. Yet, a particular black hole, TON 618, releases an overwhelming sense of awe in our chest. With an estimated mass between 66 and 70 billion solar masses, this object, located in the Canes Venatici constellation, is the most massive known black hole of its kind. This colossal black hole lies in a distant quasar, an active galactic nucleus with a luminosity that exceeds the Sun's by a factor of 140 billion. This quasar is one of the brightest objects in the observable universe. In fact, it shines so brightly that we cannot even observe its associated galaxy from Earth. A parallel universe. According to the usual assumptions of cosmology, the movements of galaxy clusters should be randomly distributed in all directions. The problem is this is not the case. Scientists reached this puzzling conclusion a few years ago when they analyzed data from NASA's WMAP. The researchers realized that the clusters exhibited an unexpectedly uniform movement. It seemed as though the galaxy clusters were falling under the influence of a gigantic, unknown gravitational force. Ultimately, astronomers identified 1,400 galaxy clusters in this mysterious galactic current. In light of this galactic mystery, NASA's lead scientist, Alexander Kalinsky, arrived at a revolutionary conclusion. Assuming the many measurements couldn't be a statistical coincidence, he declared, we don't have enough information to know what it is or to reduce it. We can only state with certainty that the world somewhere in the middle is very different from what we see locally. We don't know if it's a different universe or what really triggered this phenomenon, now called the Sirius River, is completely resumed. Fundamentally, no one can despair. Anyway, how the universe presents itself beyond our natural line of sight is still a mystery. While some researchers suppose that the structure of the universe resembles the areas we know, others suspect that objects and structures are hidden in the hidden universe and exceed our creative mind. In addition to being the cradle of stars, the Tarantula Nebula boasts two titles. It is both the largest known nebula and the most dynamic star-forming region in our galactic neighborhood. With its 2,000 light-years in diameter, the structure, also known as TR Doradus, is about 163,000 light-years away from our blue planet. The nebula's unique luminosity is due to a structure at its core that we have already briefly mentioned. The superstar cluster R136. Contrary to the official designation, we are not dealing with a deadly venomous spider, but a stellar nursery that impressively shows the natural beauty of the universe, with its breathtaking orbits of gas and dust. The most fantastic void can be seen in the thousands of objects that hurtle toward us from the atmosphere on starry nights. However, we should not forget that certain areas of the universe are also characterized by a monstrous void. For example, in the heavenly body of Hedonus, specialists have detected a vast region that is surprisingly much colder than the surrounding areas. One possible explanation is that the so-called cold spot in the cosmic microwave background, CMB, is actually a supervoid, which means a huge void extending over a region of 1.8 billion light-years. The largest galaxy, excluding the halo of the Milky Way, is estimated to be about 105,000 light-years in diameter. While our galactic neighborhood does not particularly stand out from other spiral galaxies, IC 1100 shows us what the combinations of stars, planets, and other objects linked by attractive energy can really look like. This structure, located about 1 billion light-years away in the Virgo cluster, is estimated to span an incredible 5.5 million light-years. If IC 1100 were placed at the location of the Milky Way, it would effortlessly come closer to our closest galactic neighbor, Andromeda. Now we are eager to know your opinion. Which cosmic structure has most amazed you with its extreme features? Feel free to share your thoughts, ideas, and reactions to today's video in the comments below. Don't forget to give us a thumbs up and subscribe to stay informed. And with that, thank you for watching. Take care and see you next time.